Hi, this is Shaina, and today I will be presenting our group project on predicting moral judgments in online discourse using machine learning. Our project looks at whether machine learning models can predict moral judgments in online conversations. We focus on the Am I a A-hole subreddit because each post comes with a clear community verdict, which makes it ideal for supervised learning. Our goal is to automatically classify whether a story can be judged as you're the a hole or not the a hole using a data set of 10,000 Reddit posts. This gives us a way to explore how well AI can understand moral cues and patterns in real online discourse. In this project, we focus on Reddit, which, as we all know, has become a major platform for social interaction and moral debate. The Am I the A-hole subreddit is especially useful because people share real personal dilemmas and the community can provide clear moral judgments like you're the a-hole or not the a-hole. These posts are often rich in tone, emotion, and context, which makes them ideal for computational modeling. Our goal is to see whether a machine learning system can predict these judgments from text. Using a dataset of 10,000 posts, we explore whether AI can detect moral cues, digital hostility, or questionable behavior directly from online narratives. For the background of this project, we're looking at the larger issue of online toxicity and harmful interactions, which have become more common as communication shifts to text based platforms. Even with moderation tools, identifying problematic behavior is still at a scale a major challenge. Natural language processing gives us a way to analyze the tone and framing of online posts. The Am I the A-hole subreddit is especially useful because people describe real conflicts and the community provides explicit moral judgments. These posts are long, detailed, and naturally annotated, making them a strong foundation for supervised machine learning on moral judgment. Now I'll transfer to Bashar for the methodology.
For the methodology, we first wanted to ensure that the data we're processing is clean. So we did some pre-processing. We took that data and we got a text representation. Then we did some model training, and then we did some evaluation. So for data processing, we did some lowercasing, some punctuation removal, tokenization, and then we did some cleaning for the transformer models. We also did some text representation work, so TF-IDF vectors were used, and the Distilbert embeddings were used as well. Um, and essentially, we had an 80-20 train test split, meaning that 80% of the data was used to train the data, and 20% was used to test the data. And the evaluation metrics to use for the models were accuracy, precision, recall, and F1 score. And essentially, in terms of models, we were comparing the classical NLP versus transformer-based embeddings for predicting am I the a-hole moral judgments. Now I'm going to pass it on to Jarif and Geoff that will speak about the code in detail.
Okay, so here's the code demo. We loaded our data set of about 10,000 Reddit posts from r/am I the a-hole. We're going through the data cleaning and data preparation steps, showing how the data set's imbalanced, one-hot encoding, going through removing empty posts, either deleted or empty. This accounted for 0.8% of the data set. Removing duplicate posts, cleaning up the posts themselves, removing them of text we can't understand, and some basic exploration steps, most common words, post lengths showing on average a smaller post with a few outliers in length, removing some posts that are too short or in the wrong format. Here's the distribution of word count. Model training, we did a 70-20-10 split, combining the title and the post to ensure we have all context in the post in the training situation. Here we are getting the embeddings for each post using a sentence transformer. Then in some model explanations here, we train some basic models, logistic regression, k-nearest neighbors, neural networks, SVM, and XGBoost. Here we are training them, accounting for the imbalanced data set. As you can see, these are the results. The best result being in the training being neural network and SVM. the followed by k-nearest neighbors, and in validation, XGBoost and k-nearest neighbors performing the best, and on average, SVM and logistic regression performing the worst. You can see the loss chart, charting the loss during the training for the basic neural network we used. Here we have the transformer model. We are tokenizing it and accounting for the imbalanced data set as well, loading it through PyTorch. Training it here, we're going over 5 epochs, 10 to the negative 5 learning rate, Atom Optimizer. Training it here, the 5 epochs, and as you can see, here are the results, imbalanced towards the minority, towards the negative class. Then you have confusion metrics here, and to go over the more advanced neural network we tried.
Yeah, so we also made a custom neural network, which had 3 layers. And for this neural network, we used a Distilbert function as shown here. And in this Distilbert function, we use it to make embeddings using 768 dimensions. And how this neural network worked is that it's a fast-forward neural network designed to classify the posts using the embeddings as the input. And unlike the transformer, this one did not use the sequence structure, but instead a direct mapping from the embeddings that it took as the input to produce output labels. And the architecture of this consisted of 3 linear layers, as I mentioned before, and 2 of the layers use ReLU and dropout to improve the learning and control the overfitting. And the final linear layer was used to use the learned features to provide the output, and the metrics showed that this model was able to learn meaningful patterns from the embeddings themselves. And here you can see the metrics from here, and this was our best performing model.